Hi, and welcome to the webcast, Autodesk Maya 2013 and Beyond, Animation Workflows for Games. My name is Stephen Roselle. I'm a Senior Solutions Specialist with Autodesk, and I focus primarily on Maya, as well as Motion Builder and Mudbox, and I work specifically in the games industry working with game developers who are using these tools for content creation. I also have a blog on the area called Maya at area.autodesk.com/blogs/StephenR, where I cover a wide range of Maya specific topics. So today we're going to focus primarily on Maya 2013 and specifically on the animation features included in Maya 2013. We're also going to touch on the Ultimate Entertainment Creation Suite, which is the first ever bundle that contains our two hero products, Maya and 3ds Max, dating myself there. It also contains other products such as Softimage, Motion Builder, Mudbox, Turtle, and so on. So we're going to talk about some new animation-specific workflows that have been added with this new suite. And then we're going to finish off today with something called Project Skyline, which is an animation authoring-to-runtime system. I'm not going to get into details on this now. For now, we're going to focus on Maya 2013, and we're going to talk again about primarily animation-related workflows and tools. Now, the three big areas of focus for Maya 2013 in terms of animation are animation editing, animation management, and animation reuse. Now, in terms of specific features, there are a number of features that kind of fall within these buckets, starting with some general graph editor improvements, ranging from tools for visually kind of analyzing your poses in post-pose animation using a new step tangent preview mode, as well as a really powerful new animation retiming tool for doing kind of broad retiming of complex animations. We've also added a new import-export tool set called Atom, which is very flexible and kind of easy to customize and control. And then we've also added a number of new features related to file referencing that tie both directly and indirectly into animation workflows, which I'll get into in a bit. In terms of interoperability, we've added a number of new features that are suites related that allow you to transfer data back and forth between our various products. One of which is a live connection between Motion Builder and Maya so that I can actually stream animation from Motion Builder in real time to Maya and actually see those update simultaneously in both packages, as well as some new interop tools allowing you to transfer animation between 3ds Max and either Maya and or Motion Builder by essentially transferring data from a CAT rig directly to an HIK rig and vice versa. So it is bidirectional. And then lastly, we've added some really powerful new animation retargeting tools based on Human IK or HIK, which is the rigging animation system in Motion Builder and Maya. We've added a number of improvements to the rig as well as the ability to customize the user interface. And in addition to that, we've added some really powerful tools for retargeting between HIK and your own custom rig. So you can build your own proprietary rigs and transfer animation, retarget animation between different characters. So with all that said, let's get started with the Maya 2013 animation demonstrations. There have been a number of new improvements to the graph editor in Maya 2013, one of which is the ability to preview your animations in a stepped mode. So what you can see here is I've got a keyframe animation, and I've basically got a series of poses essentially that I've animated between with interpolation between them. The first thing I want to do here actually is just take the master transform node here and I'm going to mute the Z translation. And by doing that, I can actually just have my character kind of run in place so that I can begin to analyze the poses. Now this is not new, this has been around for a while. But one thing I want to be able to do is actually go in and get a better idea of what my poses for this animation look like. So I'll grab the top node of my character here. Let's actually pull back and grab that main node there. Go up to the highest level, there we go. And I want to expand that to show all the underlying curves. Now the curves that I'm seeing here, again, are based on a series of poses. So I have one pose to the next, but I have interpolation between them. So what I want to do is just simply right-click in the timeline, and I can just convert this into a stepped preview mode. Now what that allows me to do is it allows me to step through my timeline and basically just pop from pose to pose so that I can get a really clear idea of what my poses look like without the kind of interference of the interpolation. Now this is simply a preview mode. I can very quickly and easily go back and forth between this mode and my standard mode, and now I have all of my interpolation back as I normally would. So in this animation, you can see I have my character running, jumping, falling, landing, and then continuing to run. This animation contains a number of curves on many different control objects, and if I wanted to change the overall rate of this animation at any given point, it would involve dealing with lots of keys on many curves. So as you can see here, I've got this kind of arc in the middle which represents the jump. So if I wanted to retime just that particular section of the curve, or the animation, I can go into the new retiming tool in Maya 2013, and I can drop down timing markers, which would allow me to essentially retime sections of my curve. So I can speed up or slow down entire chunks of curves independently of the rest of the curves. Now where this really becomes powerful is the ability to insert additional markers that would then allow me to change the timing within a certain boundary, within a certain range of curves. So I can have my animation slow down at the beginning of the jump and then speed up as he lands, in this case. Or I can change that and have him speed up at the beginning of the jump and slow down at the end. So as you can see, this is a really flexible tool and a very powerful tool for dealing with retiming of complex animations. There have been a number of changes to referencing in Maya 2013 that are both directly and indirectly related to animation. So referencing is very commonly used in animation workflows where you want to bring characters into environments, for instance. So here I have an environment with no character. If I wanted to create a reference, I can do that, and I can manage the reference directly from the outliner. So if I right-click in my outliner, I can now go in and, first of all, create a reference. So I'll just simply point this to my first animation file. So the contents of that file will get loaded into my scene, and now what you'll see is that I have a list of objects in my scene that are from the reference, and then I have a node representing the reference itself. If I expand that, you can actually see the contents of that reference in a graphical view. But you can also right-click directly on the reference, and you can access all of the various referencing related options. For instance, duplicating the reference, importing the reference, removing or replacing the reference, and so on. So for instance, if I were to go in and move this object around just using kind of my main master control node, I'll just move him so that he starts out on the other end of the room, and I'll maybe rotate that around so he faces in a different direction. Now everything I've done here has been a reference edit on top of the reference file. So if I wanted to swap this out with another version of the animation, traditionally I'd have to go into the reference editor. Now I can just simply right-click on this reference node, go into my reference pull-down menu, and I can simply replace this reference with another file. So I'll choose the second animation file. So now you can see it's brought in that new file, and if I play this back, now I have a different animation that has inherited that same reference edit, which was the global offset. So as another example, if I wanted to remove that reference edit, rather than going to the editor now, I can right-click in the outliner, and within the outliner I have the access to the reference edits for that particular reference. I can go in here now and I can simply select these reference edits and just remove them, and I'll have the original placement of my object back, all without ever having to leave the outliner. So let's go in and take a closer look at the animation for this referenced character. So I'm going to scrub through this animation until I get to the jump, and we'll kind of get to the highest point of the jump. And let's say that I wanted to make a couple of modifications here. I'll grab the hip controller, which allows me to control the vertical offset. And what you'll see here is that the hip controller has curves on it, but those curves are not editable or accessible. Now, this is the way Maya's referencing has traditionally worked. So if I wanted to edit this, I'd have to go to the original file. Now what I can do is I can go into the preferences, and under the animation settings for preferences, I have the ability to allow referenced curves to be edited. So if I save that and then I just refresh my graph editor here, what you can see here is I can actually take that curve now and I can begin to edit it. So let's say that I wanted to raise his body up a little bit or down. Let's actually raise him up a little bit. So if I wanted to see that relative to the original animation, one of the nice things that I can do here is I can go in and I can actually turn on my buffer curves. So if I show buffer curves, and then for this particular curve, I'll go in and I'll set my buffer curve to be displaying or in a display mode to show the reference. And that will show me the relationship. Let me actually just frame in on these few here. That will show me the relationship between the offset that I just made and the underlying reference curve. So if I make an offset, say for instance, that's too extreme, or let's say that I kind of buckle his knees here and I realize that I've made a mistake with that edit, what I can do is I can just go under curves and I can set this to swap buffer curve, and that will swap the new curve, or rather the edited curve, with the original underlying animation curve that exists in the reference file. Now I can go in and I can make changes again, whoops, and I can kind of correct the problems that I had before. So one thing to point out is that these are all saved as reference edits. So as I begin to edit these curves, I can actually view those as reference edits. So if I go to the outliner, I can right click, go into my reference menu, go into my edits, and you can see these were actually edited, or rather applied as reference edits to the curves themselves. So now I can go in and I can bake these reference edits out so that they apply to the original file. And then that way I would have them in the original source file, or I could leave them as reference edits on top of that file. Another powerful new animation feature in Maya 2013 is Atom, also known as Animation Transfer Object Model, which basically allows you to transfer animation to and from characters, either the same character or different versions of the same character, or even different characters altogether. So what you'll see here is I have an animation of my character walking by and making a turn. I've got a couple of things going on here in addition to the base animation. I have a constraint here that's driving the head so that he'll actually look at that constraint as he walks by. Now, I also have an animation layer that's doing a correction on the arms so that the arms won't actually penetrate through the legs as he's walking. So, including not only the animation as well as those additional things, I can save those all out into the Atom format. So, we have a couple of additional things as well that I want to talk about. First of all, let's bring up my Atom menu set here, and we'll just kind of leave that up here. First thing I want to do is create what's called a template. Now this isn't necessary, but it's actually quite useful for kind of predefining the different parts of animation that you may or may not want to retrieve. So I'm going to take all of the nodes that are associated with this character, and I'm going to put those into a template. And we'll just call this template my template, and I'll just overwrite the one that's there. Now what I want to do is basically go in and just save all these nodes out into that template. So that will save out an XML format, basically listing all the nodes that are going to contain animation. Now the next thing I want to do is create views within that template. So I'm going to create one view for the upper body. So now I'll go in and I'll just select all of the nodes that are associated with the upper body, everything except for the hips there. And I'll also select this locator here, which is the head constraint. And I'll apply those to the template. So all it's going to do is it's going to push additional information into the template. Now I'm going to take the base controller, the hips, as well as the feet controls, and I'm going to put those into a separate view. So we'll call this lower body. So now I've created two views within a single template, upper and lower body. So the next thing I want to do is actually export my animation. So I'll go into my export animation options here, and I'm just going to take everything and I'm going to export animation as well as static values, which I'll talk about here in a second. I'm going to turn off baked animation because I don't want to actually do any baking, and I want to include set-driven keys and constraints. So what this will do is it will save all of that into a single animation file. So I'm just going to call this my walk anim. We'll save that out, and I want to save everything that's selected. Everything else should be fine. We'll save out that animation, and now we want to reapply it to a different character. So here you can see I have a very different character, but with a similar rig. It's not exactly the same, but it's similar. So I have controls that are already set up, but I have no animation. If I push play, there's nothing there. I also have a constraint target object for the look at, which is actually different than my other scene, but it has no connection to the head. I also have no animation layers. So what I want to do here is I want to import animation onto my character, first of all using the template that I just created. So I'll set this to template, my new template, or rather my template. I'm going to replace all the existing animation with their time range from the file, and I'm going to use the upper body template, or rather the upper body view. So now I'll go in and I'll load the my walk animation. I can just select a single object that is connected to this view, and I'll simply apply. So what that's going to do is it's going to apply all the upper body animation to my character. So as you can see, it's created the upper body animation. It's also not only animated the constraint, but it's created the relationship between the constraint and the target object. And then additionally, if I go over to my animation layers, what you can see here is it's also included the offset animation layers for the hands. So again, it's able to preserve all of that from a single XML-based animation file. So let's go in and import the rest of the animation on the lower body. And this time I'll just grab a foot controller. I'll switch my view to be lower body, and now I'll simply import that onto the feet. What you'll notice here is that it did indeed find the other foot, and it did indeed apply the lower body animation. But it didn't actually apply the rest of the lower body animation correctly. So there are a number of things that we can do to resolve this. For starters, we can go in and we can look at the original animation file and figure out what the problem is. So here you can see I have a node called Spaceman Hips Anim. If I actually take a look at the file, My Walk Anim, what I can see is if I search for hips, I'll actually find that the hips attribute, or the hips node rather, in the Atom file is actually named differently. So here it's named Dummy instead of Spaceman. So I have a couple of nodes that are named Dummy as opposed to Spaceman. This was done on the export side. So I can actually go in, because this is an XML file, I can actually either manually or through some sort of an external script, say a Python script, I can do a search and replace on this file, make a copy of it, and then import the newly created modified file and have that affect my character appropriately. The other alternative to this is on import, I can actually specify some simple search and replace and prefix or suffix options. So now if I were to go in and grab the hips as well as the base controller here, I'll just set this into selected mode, and rather than manually editing the XML file that contains the animation, I'll just do a simple search and replace, looking for the word dummy and replacing that with the word spaceman. Now I'll simply apply that, and bam, now I have the new animation on the upper body, the lower body, as well as the search and replace that has been applied on the hips and the master control. So now I have all of my animation intact, including my constraint, again including my animation layers, as well as the additional nodes that may have been slightly different from the original file. Atom can also be used for other purposes. For instance, static values would allow you to save simple poses on characters and or other types of objects. So it could also be a way of externalizing the transformation values of certain types of objects. So for instance, when I export a static value or a pose, I can then re-import that onto another character or a different version of that character. So if I just go in and reset my values here, what I'll do is I'll just quickly go in here and I'll just select all the curves in my scene, and that would basically allow me to select all the control objects. And then I've got a couple of other objects to select. I'll select the arms as well. I'll simply go into selected mode, I'll replace based on a string, and then I'll just choose, instead of an animation file, a pose file. This is also in an Atom format. So I've got a file here called weapon draw. I'll just simply load that and replace. And now I've put my character into a weapon draw. So now I can create as many variations of this pose as I need to, externalize them, and apply them to other characters in different scenes. There have been a number of nice improvements to the HIK rigging animation system in Maya 2013, beginning with the actual behavior of the rig. So here I have my Sven character already rigged and set up. And what you can see here is that we now have a syncing that happens between FK and IK. So if you were to rotate the FK, the IK will follow. If you rotate, or rather move, the IK effectors, then the FK will follow. These used to be out of sync until you actually release the mouse. Now they say in sync at all times so that you can get a kind of better visual feel for how your character is moving. Another very nice improvement is the ability to customize the user interface for your character controls. So for starters, we've actually unified the definition and the control tabs into a single UI. We also have exposed the character target and character source controls at a higher level so they're easier to access. But beyond that, in terms of interacting with your character, using the selection controls here that allow you to indirectly drive the selection of your character, you can actually customize this look. So I'm going to bring down the customization settings here, and first thing you'll see is that we now have a much smaller kind of screen real estate for the default character control. Now this is a new A stance, but you can also load custom UIs that allow you to set different looks. For instance, we have two default or built-in looks. One is the A stance and another is the T stance. The nice thing about the T stance is that it's scalable so that I can get a really close-in look if I need it, or I can make it more compact if necessary. Now we also have the ability to load other custom looks. For instance, I've created two for Sven. I've got one with the A control, or the A layout, and I've got one for the T stance. Again, this one is scalable, but they both have the exact same selection controls so that I can go in and I can select various body parts, and I can also do all my various pinning as well as reach settings in here. So this is a nice new way of kind of visualizing your characters from a user interface standpoint. You could take this a lot farther. I've got a couple of examples here showing, for instance, a Superman character where the hand controls have actually been exposed at a higher level, and you'll notice his stance is slightly different as well. Just to show you another example, let's go in and bring up a Gremlin character, and you can see that the layout of the controls is very different from this character. So we provide XML templates that basically allow you to, or help you get started with these layouts. So you can see that each one of these is an XML file. You simply save them out in the appropriate folder, and the files themselves are actually simple XML descriptors. So you can see here I've basically got coordinates for each controller, both FK and IK. So I can basically change this file, save it out as a new version, point it to a new image, and I'll have a new custom setup. So we have the ability now to, of course, source multiple images for our backgrounds as I showed you in the earlier example. So it's very simple and straightforward, but it gives you a lot of flexibility in terms of visually controlling your different and unique characters. One of the cooler new features that I want to show is a Suites Only feature, which basically allows you to create a live connection between Maya and Motion Builder, so that we can basically create animation in Motion Builder and stream that directly to Maya. So what I have here, of course, is just this standard HIK rig on my Sven character. So what I'm going to do is I'm actually just going to pull Maya kind of off to the side, and I'll just show the live connection process. In order to send this character over to Motion Builder, I just have to select just any effector or control object on the character, and I'll just say send to Motion Builder as live connection. This will basically give me the option of connecting remotely or locally. So that if I'm connecting remotely, I can actually just enter in the remote IP address. If I'm connecting locally, I'll just use the default. So we'll send that to Motion Builder, and within a few seconds, you'll see my character open up on the Motion Builder side. There it is. And I get a visual bar indicating that I have a live connection between the two. So you'll see here now that if I pull in, I have the exact same character with the exact same rig. And now if I were to go in and begin to edit that rig, whether it be with IK and or FK, you'll see that as I edit it on the Motion Builder side, I have a live dynamic connection to Maya. So this would allow me to basically go in and apply animation using various Motion Builder tools. So for instance, the story tool in Motion Builder is a very powerful tool for creating kind of non-linear animation. So what I'm going to do here is I'm actually going to just insert a character animation track and put my character into that track. Now I want to apply a clip to this track. So let me just rewind to frame 0 here. I'll actually just pull back, and I'm going to drag in my simple run clip. Now you'll see, if I basically come in and scrub the timeline, is that I've got a run animation applied to my character on the motion builder side, and as I scrub the timeline, you'll see that run animation will simultaneously update in Maya. So again, if I go in and scrub the timeline, there you can see the exact same animation in both viewports. Another thing I can do on the story side would be to layer a subtrack onto this. So I'll create a character override subtrack, and then I'll go in here and I'll create a bone mask for this particular character. So if I just expose down here under my character list, I can either do the full body composite, or I can just choose the upper body and actually turn off the lower body. So now I'm basically going to be overriding the upper body with a new animation. So let's pick something like my jump clip, and I'll just grab my jump clip and I'll paste that on top of my run clip, and now you can see that it's overriding the upper body animation. So now again, when I scrub through my timeline, I have my character running and then spreading his arms, and I've essentially combined two unique animations. This is just one example of the kinds of things that you can do on the motion builder side that weren't possible directly in the Maya side. This allows you to actually work with motion builder and Maya simultaneously. Another thing is that you'll notice is that the environment has not been sent over to Motion Builder. So this allows me to simply send what I need, just the character itself and the animation, to Motion Builder, deal with the animation on the Motion Builder side without having to send the entire level as a reference on the Maya side. This also allows me to take advantage of Maya's referencing so that I can actually, for instance, reference in a level or other characters into my Maya scene, see those in conjunction with the animation I'm working with in Motion Builder without having to send all of the data back and forth, simply sending the bits and pieces that I need. With the introduction of the Ultimate Entertainment Creation Suite, it's the first time we've actually bundled 3ds Max and Maya in the same suite. So now, as part of that, we've integrated the one-click functionality between Max and Maya, so that with a single click we can send objects back and forth between the two packages. But in addition to that, we've also added functionality that allows us to essentially share animation data between CAT rigs in Max and HIK rigs in Maya. So what you'll see here is I have my Sven character all rigged up with a CAT rig. You can see here I've got controllers similar to what I have with HIK. So I've got controllers for the arms and the body part, various body parts, and so on. So if I undo that, let me go back, and rather than creating animation from scratch, we'll actually use one of the strengths of CAT, and that is the ability to apply procedural animation. So I'm going to go over here to my CAT controls, and first of all I'm going to create an animation layer that I can put some new animation on, and then I'm going to load a procedural animation into this. So you can see here I've got a variety of built-in presets. For instance, I've got a game character creep, run, and walk. Now these are all presets that are based on various parameters. So I've got controls, for instance, for my pelvis where I have a roll, twist, weight, and so on. I've got leg controls for things like knee angle, twist, swing, and so on, as well as arms and other body parts. So I could go in and I could configure all these body parts and procedural values. Or if I've already got something that I like, I can actually import that from an external file. So I've got a file called svenrun.cmp. I'll open that up and I'll apply that to the existing layer. Now what that's going to do is it's going to load all the various parameters that are in that template file onto the CAT rig. And now when I go in and I just simply push play to make that active, you can see here that now I've got an animation of a run cycle that was created procedurally. So this could be modified and tweaked to look a little bit different if I wanted to raise his arms or make his legs a little wider. I could do that using procedural values, but as soon as I get it to a point that I'm happy with, I can send this to Maya for further use. So if we pull this off to the side and we take a look over here on the Maya side, what you'll see here is I've got just a simple environment on the Maya side. Now this could obviously be a lot more complex than it is, but for now we're just going to work with this environment that we have. So what I want to do is basically go in and I want to take everything in my CAT rig and I want to export that. So I'm actually going to pull back here a little bit just so I can get to my my layer window here. I'm going to take the CAT rig, and I'm going to select everything in the cat rig. That's all the controllers associated with this. And then I'm going to send that cat rig with all the associated animation over to Maya. So I'll go to Send To. I've got Maya, Softimage, Motion Builder, Mudbox here. I'll choose Maya. And what I want to do is just simply update the current scene. Now that will export the animation as well as all of the various joints and the mesh as well, anything associated with this character. It'll send that to Maya, and then Maya will begin to import that. So now you'll see that I have the same character on the Maya side, and if I scrub through my Maya timeline, you'll see that I have the exact same animation. You'll also notice the skeleton that was brought across in the mesh and so on. Now the interesting thing about this is that this character now has been pre-characterized for use with HIK. So if I go into my character controls and I go into the definition tab, you'll see that it has already been defined as a character. It's already been named based on the character name on the Mac side. So I don't really need to define it. All I need to do is actually bring up my control rig. So you can see here I have my control rig already accessible and enabled. I can now actually begin to use my standard character controls to go in here and drive my character. But what I want to do is actually take the animation that's currently on the skeleton and put that onto the character. So I'll go back to the animation. Again, you can see if I scrub the timeline, it's all there. And what I want to do now is simply plot this animation. Now I'm actually going to just maximize my view here so we can see what's going on. I'm actually going to go in here under Bake, and I'm going to bake to the control rig. That's going to transfer the cat animation that was created on that original skeleton, and it's going to put it onto the control rig. So now you can see I still have the exact same animation, but now it's on the control rig itself. So if I wanted to make modifications, I have the power of the control rig to basically apply layers of animation on top of the existing animation. So let's say that, for instance, I wanted to change the placement of his hands. I can go into the animation layers here, and actually first of all I want to go to the character controls. I want to go under Edit, Controls, and I want to create a new animation layer for the entire control rig. So it's going to create an animation layer that I can now use to modify the existing animation. So now I can say, for instance, I wanted to raise the hand controls. Again, let's just go back and make sure I have the appropriate controls selected here. And we'll go in and we'll just add a simple offset to this. So let's just say right here, I wanted to raise these up so his hands are much higher. I'm going to create a simple animation offset. So now you can see he's running with his hands much higher up towards his upper body. So now if I wanted to send this back to Max, I have a live connection between the two. So if I pull my interface up here a little bit, you can see it says connect to 3ds Max. Let's actually pull this off to the side once again so we can see both of these simultaneously. I'll say connected to Max, update. That will send the changes back over to Max, and I can view them on the same exact cat rig. So now when I take a look on the Mac side, we'll pull into this, and as you can see, I have the same character, but now with two tracks. So I have the original cat motion layer. If I solo that, you can see the original animation intact. And then I have my new layer, which is the HIK layer. If I solo that, you can see the difference there with the arms raised. So now I can send modifications back to Maya, or I can work with this as I need to on the Mac side. One of the more powerful new HIK workflows in Maya 2013 is the ability now to dynamically retarget animation from an HIK character to a custom rig. So what you'll see here with my Sven character is that I've got a custom rig driving the various body parts of my character. For instance, arm controllers, hip controllers, head controllers, and so on. So these were all either built manually or they were built procedurally through some sort of a custom rigging script. But again, these are not HIK, these are custom. So now what I can do is, using the standard character controls user interface, I can go in and I can map a relationship between an HIK definition and my custom skeleton. So what you'll see here is I've basically mapped the shoulders, I've mapped the elbows, mapped the hips, I've mapped the neck joint, I've map the leg and knee joints and so on. So it's basically a similar mapping process for creating a standard HIK skeleton, or defining one rather. So all we've done here is we've just defined our character relative to the skeleton. The next step is to actually define the rig controllers as well. So we have a new tab here called Custom Rig. You can actually create this through the main menu under Custom Rig. And what this allows you to do is, instead of mapping the joints, it allows you to map your controllers. So for instance, for the body, I've got my base controller here. For the head, I've got my head controller. I've got elbow controls. I've got hand controls, and so on. And it's just a matter of basically selecting the controller that you want to apply, right-clicking, and just saying Assign Selected Effector. So this is a fairly simple rig, but this could be applied in more complex examples as well. But for the sake of the demonstration, we're just going to keep it simple for now. So I've got not only a few controllers, but I've also got controls, or rather settings on those controllers that determine how they behave. For instance, the hand controller not only drives the arm IK, but it controls the FK of the wrist. So I've got the ability to map translation as well as rotation. And then I've got some offset controls, which I'll talk about in a bit. So in some cases, controllers are going to be FK, in some cases they're going to be IK. For instance, the head in this case is only going to be an FK controller. Actually, I lied. Oh, that is an IK and FK. But anyway, you get the point. You can have FK or IK for any given controller, and independent control over those. Now once all this is set up, now the custom rig has been characterized. Now I can actually bring in another character into my scene. So I'm actually just going to bring in a simple character from my visor. So in the visor now we've got several pre-rigged human IK characters that you can work with to kind of explore and experiment with. We've also got mocap examples that have also been characterized. So what I'm going to do is I'm going to take this cartwheel example, I'm going to drag that into my scene. And what you'll see is I've got a simple kind of dummy mesh and a skeleton that has some motion capture applied to it. Now these are pre-characterized, so this will actually show up in the character list for either source or target. So what I want to do is now apply my mocap example as the source to my target custom rig. Now as soon as I apply that, you can see now my custom rig will begin to follow that motion. So now I can actually go in and I can take, for instance, the master controller here, and I can kind of pull that off to the side, and I can begin to kind of compare these side by side. So these look pretty good actually. What it's doing is it's kind of comparing the joint rotations, the joint angles from the source character to the target, and then it's kind of reverse engineering that to transfer that ultimately to the end effectors of the control objects. So the original retarget is happening on a joint-to-joint basis, and the control objects are following the joints, but when I do the bake, it's actually going to do the bake onto the control objects. So a couple of things to point out here. Let's actually pull this off to the side. You'll see that as my character goes from kind of the leg contacts on the ground to the hand contacts, the hands are actually solving based on standard FK. They're not actually solving based on IK. So what I can do is a couple of things. I can actually go to the control objects. I just needed to refresh that so it had my new character controls for Sven in here. So what I want to do is actually grab the hand controls, and you can see that even though I have a custom control rig tab, I still have the ability to go into my standard HIK controls. And here I can control things like the bias between IK and FK. So right now I'm turning on full IK as opposed to FK. And here I'm turning on IK for the wrists as well. One thing you can see here is if my original character moves, my entire character is going to follow. So if that's true, if I control any one of these joint angles, so if I rotate the knee here, you can see how that will indirectly, or I should say directly, drive the knee of my target character. But another thing I can do is I can actually go into the settings here, or rather the properties. I have the ability to solve in a number of ways. So here I can go in and I can adjust things like the legs and the collar offsets, as well as things like floor contacts. So if I go to floor contacts under hands, I can turn these on, and what that will do is it will actually use the ground to determine where those should hit, where those should stop rather. So now if I go in and I grab this original object and I start to move it around, you can see that if I move it up, then I get no change in the rotation of the wrist. If I move it down, the wrist will contact the ground and then the arms will react. Now I have the same controls on the hands as well, or rather on the feet as well. And then ultimately I can take all this and I can bake it to my custom rig. So if I wanted to now take this a step further, I would actually come in here to my character controls. I would go under my bake settings and I would simply bake that to the custom rig. that will transfer all the animation from my original mocap object and apply that directly to the rig. So now I can use animation layers, for instance, to go in and make further modifications. So for instance, as this character is moving here, I could go in and I could actually put this control object into an animation layer. Let's actually just create a new one there. And then I can go in and I can say, for instance, I wanted to pull this in a little bit and maybe rotate it this way, set a keyframe, and I've created an offset keyframe on top of my custom rig. So now I'm no longer doing a live retarget. I've done a bake animation, and then I've created an offset for that one particular control object so that I can do corrective animation on top of the baked retarget so that I can refine it further. So along the way you have a number of methods for essentially kind of refining and controlling the way that retarget happens onto your custom rig. So that wraps up the Maya 2013 portion of the webcast. For the last part of the webcast, we're going to talk about Project Skyline, which is an animation authoring-to-runtime system. Now you may have seen this before at different times. This was actually debuted a year ago at GDC 2011. We showed updates to it in at GDC 2012. Before I get into this, I want to quickly bring up our kind of general legal statement about this. This is a technology preview. What you're about to see is not an actual product, and there are no guarantees that it will ever become a product. This is just a kind of a window into some of the technology that we're working on the game side for our GameWare group. So a little bit of kind of front-end information about Project Skyline. It is, again, a forward-looking technology, and it's intended for a number of things: authoring animations, creating animations, as well as assembling them into gameplay, so building things like blend trees and state machines and general game logic, as well as inspecting and debugging the results, so basically being able to author animation in Maya, build something like a animation or tree or state machine in Maya, and see that update dynamically in a live running game so that you can then go back and make changes to the original source files. So Project Skyline basically is intended for animators, TDs, and programmers. So all of these people kind of have the same view into the game from an animation perspective, and everybody can work with the same assets and using the same interface all at the same time. And again, it's a live connection so that an artist can basically make changes to the gameplay without having to have a programmer do it for them, as was done in the past. So now let's move on to the demonstration. I'm actually going to switch over to a recording from the demonstration I put together this year for GD 2012. I'm going to go into quite a bit of detail about all of the many updates that we've made over the last year. Hi, this is Stephen Roselle. I'm a technical specialist at Autodesk, and I'm going to talk to you about Project Skyline and Hyperspace Madness. Hyperspace Madness is a game that we've created internally at Autodesk that we're using as a test bed for our various GameWare products. And we're also using it as a test bed for Project Skyline, which is an animation authoring and runtime system. So all the animation behavior that you see here was created in Maya and then authored in Skyline, which exists on top of Maya. So what we're going to do here in Maya is we're going to load the Skyline project, and you'll notice that we do have a Perforce in revision control integrated, but we're going to disable that for now. And we're actually going to take a look here at the library of assets that we have available to us. Now to actually get those into the game, we would use something called the game trace, which is a layer on top of Maya. Now I've just connected to the running game, and you can see here side by side I've got a live connection between the running game and the Maya viewport. So I've actually essentially discovered the assets in the game and loaded those into Maya. Now I can also switch to a Maya camera control. So what we're seeing here is we're seeing actually the game camera, which is being controlled by the typical Maya camera controls. And these are actually synced. You can turn the sync off, or you can have the game control camera back. So now I'm actually using the game to actually drive my character. So one thing that you'll notice is that as I'm actually triggering these different animations, whether it's a run or a crouch or a shoot, I'm getting these bars that are highlighting and kind of displaying in the bottom of my UI on the Maya side or on the Skyline side. This is the time trace, and this is a graphical representation of what is actually happening in the game, or what has happened. So you can see I can actually pause the game, I can go back and I can scrub the timeline, and I can replay the game. So I can go back in and I can start to analyze problems, and I can start to look for problem areas and diagnose those problem areas in order to quickly fix them. Now we also have a node editor. So I'm going to drag the existing behavior into the node editor and take a look at the authoring side. What we have here is a complex node structure that basically kind of defines the behavior that we were seeing in the game as I was running the character around. So what I have is a series of state machines that are all blended together. So I've got a body state machine, and in that body state machine I have a series of states with connections between them. For instance, I can go from an idle to a jog to a run to a fall to a land, and ultimately back to the idle. Now if I dive into any one of these states, you can see that the states themselves are complex node structures. These are actually the animation blend trees, where I can blend a left jog and a right jog with a center jog and so on. So we'll come back to these later, but let's pull out here a little bit. So let's say that I wanted to start from scratch with a simple state machine. So I'm going to create a state machine, and we'll name that, for lack of a better word, simple state machine. Now every state machine has to have at least one state within it. Generally it will be a lot more than that, but for now we're just going to go into this state, or rather this state machine, and create a simple state. Now we'll call this our idle state. So within the idle state, we're going to create a simple idle animation. But for starters, we're just going to create the simplest clip that we can, which is an empty clip. Now this is going to basically put my character into a T stance. Now this would have been defined on the Maya side. So we're going to go back to the state machine, and we're going to basically feed that state machine into our game. And now, if you look at the game, within a few seconds, our character will immediately position into that T stance. So I've essentially lost my original behavior. I no longer have the walking behavior that I had before. Now I just have the simple T stance, which is the single state, the single clip within the single state within this state machine. So let's go back to Maya, and we'll bring in some new animation. So we're going to look at the Skyline project here and go into the clip groups. And I could use an existing clip, for instance the existing idle, but I'm actually going to start from scratch here and create a new one within the locomotion clip group, and I'm going to call this idle new. And then I'm going to load a Maya file, which would have been pre-created using something called a skeleton definition. So this is an idle alternate, and it's going to contain the skeleton definition, which is basically the node structure, the skeletal structure of my character, as well as some clip information which determines the beginning and end of the animation, and of course the animation itself. Now this was actually animated with a rig, but it could have just as easily been animated with something like Human IK. So I'm actually going to now drag that new clip that I just created, and I'll go over here to my Skyline project, and you'll see here highlighted in yellow, idle new. So idle new, I'm going to drag that in and replace the empty clip within my state. So again, this is my idle state. And as soon as I do that, what you'll notice is that now the animation that was contained within that Maya file is now fed into my game via this clip. So now let's go back up one level and do something a little more complex and create a new state that I can transition into. So we'll just rename this new state our jump state. And then I'll go into that, and I'm going to bring in a clip that already exists. So rather than doing the same process, I'll just use a clip that exists within my weapon clip group called idle jump weapon ready. We'll bring that in and we'll feed that into the output of the state. Now I have two states, but I have no transition. Now I can set the jump idle state, or rather the jump state, to my initial state, and you'll see that immediately update in the game. What I really want to happen is a transition. So I'll set my idle back to the initial state, and then I'll drag a transition over to the jump state. Now what's going to happen is it's just going to immediately transition into the jump state. But what I want to actually happen is I want this to happen based on a specific AI event. So I'll type in an AI event called doJump, and now when I hit the A button on my gamepad, it'll automatically trigger that transition from the idle state to the jump state. So now again, when I hit the A button, it's going to transition into the jump state, but it's not doing any kind of a transition. So, or rather any kind of a blend. So I'm going to go in and set a crossfade transition for the blend, so that now instead of popping, it'll immediately, or rather gracefully, transition from one state into the next. Now I'll connect the jump state back to the idle state, and I'll basically do the same thing. I'll go in and this time, instead of using an AI event, I'm actually going to use the end of the clip as an event. So I'll say using event fired end of clip will basically determine that when the jump state is over, it will crossfade transition back into the idle state. So now I have essentially a loop. The first is triggered by the do jump event, or the A button, and then the transition back into the idle is determined based on the end of the jump clip. So again, it's essentially a loop. Now the real beauty to Skyline is that if I need to make a change, for instance, to the idle clip, I can actually go back to Maya where the clip was created or where the animation was created, and I can change that on the Maya side. So what I'm going to do here is actually I'm going to change the vertical placement of the hips and the hands so that it transitions at a kind of better starting location. So I'll go in and I'll grab the translate Y curve for the hips, and I'm going to actually just kind of move those up a little bit. Let's pull out here a little bit. Now I'm going to move that curve up, and you'll see his hips are actually moving as I do that. Now his hips are actually, or his center of gravity is at a higher location. I'll do the same thing with the hands. I'll grab the hands, and I'll grab the translate Y curves for the hands. Let's frame in on that. I'll take these curves, I'll move those up a bit, and now notice his hands, that's a little too much. Let's bring those down. Notice his hands are higher. So now what I want to do is actually keyframe those, or actually process those so that those will go into the game. So I've corrected the animation. Now I'm going to go into the clip editor, which is a part of Skyline on top of Maya, and I'm going to process that. That's essentially going to bake that animation from the rig to the joints and immediately process that into the game. Now you'll notice that the hip location for the idle is at a higher point than it was originally based on the change that I've made to the animation on the Maya side. And again, that was pretty much instantaneous. So let's get back to the more complex node structure that I had before. I'm going to bring in the body state machine that I was previously working with, which has the standard behavior, the running, jumping, crouching, and so on. And I'm going to dive into that node structure and take a look at a few of the transitions. So I have a jog to a jump to a fall to a land. We're actually going to take a closer look at the transition between fall and land. Now if I look at this, I have a complex node structure that's actually defining how that transition happens. So I'm actually getting some data from the game, including the velocity and location of the character, and then I'm doing a raycast to determine how far away from the ground that character is in order to determine when the transition should happen. So I actually want to take all of this and create a compound out of this so that I can reuse it for later. So a compound is basically just encapsulating a complex node structure. So we'll just call this a fall to land compound. And I'm actually going to tag that with a less than name as well, because there's an attribute in here that I actually want to publish or expose essentially. So I'm going to dive in. And this is a value that's actually hard-coded. This is a value here that's determining how far away, based on time, it is from the ground before it does the transition. And you see I've exposed that as the less than attribute. So we're going to export this compound so that I can use it later, and that will show up now in my node library on the right hand side. So when I type in FAL, that'll automatically filter my fall to land less than, and now I can drag that in and reuse it. And again, notice the attribute that I published, the less than, is now reusable. The last thing I'm going to do is tag this as a condition so that I can actually use this on a condition or transition. So now I'll go back to the node editor here, and I'm going to break the connection from fall to land, and now we'll go back to the game. So notice what happens when I jump. As soon as I jump, when he jumps, he no longer knows how to get to the land. He does the jump, fall, and then he stops because he doesn't know how to land. So now I'm going to go in and I'm just going to create a simple transition, and remember what that will do is it will immediately transition from the fall to the land. So now when I go in and I jump, he's going to immediately transition into the land at the very top of his fall. So you'll notice that his knee actually moves up right there when it starts to fall, which is not what I want. I actually want this to happen based on the distance from the ground. So I'm actually going to apply the existing fall to land less than transition, and I'm going to say that I'm going to use a value of 0.2, which is basically 0.2 seconds from the ground, so that regardless of whether he's jumping from an idle or whether he's jumping from a two-story building, he's always going to transition into the land at the same point relative to where he hits the ground. So as you can see here, I'm jumping from a higher point, but it's still going to transition at the right time. Okay, so we've got the body state machine pretty much working. Let's go back in and add a little bit more complexity to this. So again, right now, all I have is the body state machine. But if you'll remember, I actually have a weapon state machine as well that I was using earlier. So you'll see now if I run around and I start to shoot, notice that when he shoots, he's actually shooting from the hip. He's not reacting. His body is not moving in order to shoot. So he should be raising his arm and aiming his weapon when he shoots. So I'm actually going to layer on a new state machine, or a separate state machine rather, called the weapon state machine. So I'll just bring that in, which it was a state machine that was pre-created and saved out. I can bring that back in, and now I can blend that using a layer blend node. Now the layer blend node itself is actually a compound, so this is actually a complex node structure, but as an artist all I care about is that it will actually take the output of two states and blend them together. So I'm going to take my body state machine, put it into the first layer, weapon into the second layer, and then the layer blend can either be an override or an additive. So right now it's an override, so the body state machine will override the weapon state machine will override the body state machine, so that it'll basically composite the upper body animation on top of the lower body. But watch what happens when I crouch. When I crouch, depending on where I aim, I get different results. If I crouch and fire forward, he stays in a crouched position. However, if I fire to the left, notice how he actually stands up and his feet can actually go below the ground. That's actually a problem, and that's actually a result of one of the underlying clips. So if I take a look at the quick fire state within the body state machine, you'll see that I've got several clips that define how my quick fire happens. I've got a left clip, a right clip, a right 90 degrees, right 180 degrees. I actually want to look at the left 90 degree clip. So we'll go back to Maya and we'll find this clip within our clip library over here within our project, and I'll drag that, or rather open that in Maya. So when that opens, you'll see the animation that is defining or creating this clip, and you can see it's basically an animation of the upper body shooting, and there's a little bit of animation on the lower body, but that really shouldn't be affecting anything, because what should be happening is I should be masking that out. So we have the concept of bone masks that are associated with the clip. Now watch what happens when I turn on the upper body bone mask and go back to the game. Now it's masking out everything except for the upper body, so that only the upper body is affected. So the last thing I want to fix here is the way that the arm, or the way that the arm doesn't aim at a target when I fire. So up close it isn't really obvious, but when I go into a first person point of view and I aim up really high, you can see that the arm doesn't try to reach the target. It actually fires straight ahead using FK animation. So we've integrated HIK into Skyline so that I can actually use HIK to make changes to an FK animation. So what I'm going to do is bring in an HIK correction compound, which is actually made up of a bunch of other nodes, and I'll just splice that into the existing connection. And if I dive in here, what I can see is that I'm actually getting data from the game. I'm actually getting the target data from the game, and then I'm using HIK to point the arm at that target and essentially overriding the FK animation. So if I add that HIK correction, now you'll see that when I go into POV mode, the arm will actually point directly at that target using HIK. So it'll essentially use HIK to correct the underlying FK animation. So the last thing to point out is that we've also integrated Skyline into Unreal. Now, the game you saw before, Hyperspace Madness, was actually running on Unreal Engine. And here you'll see that we've got Skyline integrated as a node within Unreal, or within Unreal Editor, or specifically Matinee. So you can still use Unreal animation tools just like you always would, but you can basically use Skyline as a node within that. Now here you'll see the game level in Unreal Editor, and if we take a look at the character, you can see I'm now driving the character using the same game controls and triggering the same animation blend trees that I had authored on the Skyline side. So as you can hopefully see, Skyline has come a long way since it was first introduced at GDC last year. It is truly a complete animation authoring to runtime system that allows you to not only build complex animation behaviors, but also to iterate on them very quickly and get real-time feedback from the game and make changes based on that feedback in Maya and see it propagate or update in the game pretty much instantaneously. So stay tuned for more updates. So that wraps up the demonstrations and the webcast. And again, my name is Stephen Roselle. If you enjoyed the presentation and want to see more, learn more about Maya, definitely check out my blog, Maya on the area. But for now, that's a wrap, and we'll see you next time. Thanks.